Hey everyone, and welcome. So, if you've ever made the jump from coding on a single machine to a distributed system like Spark, you've probably hit a really weird wall. You know, where your variables just stop working the way they're supposed to? It's a super common problem, and it all comes down to sharing information across your cluster. Let's dig into exactly why that happens, and more importantly, how you can fix it.
Yes. This question. This is a classic welcome to distributed computing moment, isn't it? You write code that looks totally logical. You set up a counter, you tell Spark to add to it inside a loop or a map, and then at the very end, nothing. The counter is the same as when you started. It is so frustrating, but it's also a perfect way to understand a core concept in how Spark works.
So it all starts out perfectly normal, right? On your driver program, which is kind of the main brain of your operation, you just declare a variable. Counter equals 0. Simple enough. So far, so good.
Okay, now here's where things get interesting. When you ask Spark to do something across all your data, like a map operation, it can't just magically run your code everywhere. It has to package up your instructions and any variables that code needs into a neat little bundle. That bundle is called a closure. Think of it like a self-contained work package, all ready to be shipped out to the worker nodes.
And this is the absolute heart of the problem. When that package, that closure, arrives at a worker node, the worker doesn't get a link back to your original variable. No way! It gets its own, fresh, independent copy of the counter variable. So when your code on that worker adds 1 to the counter, it's only changing its local copy. That update is completely isolated and never, ever makes it back to the driver.
So, after all your worker nodes have been busy processing thousands of records, you go back to your driver program and ask, okay, what's the final count? And the answer you get back is 0. Why? Because from the driver's point of view, its original variable was never touched. All that hard work on the workers might as well have been happening in a totally different universe. So that's the problem. How in the world do we actually reliably collect and add up results from all of those different workers? Well, thankfully, Spark has a special tool designed for exactly this kind of gathering job.
And that tool is called an accumulator. Now, it's a shared variable, but it comes with some very strict rules. Worker tasks can only add to it, that's it. They can't even read its current value, which is part of what makes it so fast and safe. So the driver sets it up, the workers all chip in and add to it, and then, only at the very end, the driver is allowed to look at the final, correct aggregated value.
And you know what the best part is? Using one is unbelievably easy. Step 1. On the driver, you just create it with a starting value, usually 0. Step 2. Inside your code on the workers, you just use the plus equals operator to add to it. And finally, step 3, back on the driver, you just call .value to get the real final total. It's that clean. Now there is one really crucial detail you need to know about these. Spark gives you a guarantee. If you use an accumulator inside an action, that's an operation like count or for each that actually kicks off the job, every update will be applied exactly 1 time. Perfect. But if you use it inside a transformation, like map, things get tricky. Spark might need to rerun a task if a machine fails, and if that happens, your accumulator might get updated twice. So the big takeaway here is, for reliable counting, always use accumulators inside of actions.
Awesome. So we've totally solved the problem of getting data back from the workers to the driver. But what about the other way around? What if you have a really big lookup table? You know, maybe a few megabytes of data that every single task across your entire cluster needs to use.
Well, if you did nothing special, the result would be a disaster for performance. The default behavior is to bundle that big table into the closure for every single task. If you have 1,000 tasks, you're sending that same chunk of data over the network 1,000 times. It's a huge bottleneck. The solution? A broadcast variable. It sends that big table to each machine just 1 time, where it's shared by all the tasks running on it.
And that's exactly what a broadcast variable is. It is Spark's super optimized tool for this scatter pattern. It's all about distributing a large read-only piece of data out to all your workers in the smartest way possible, caching it on each machine so it's ready to go.
And just like accumulators, Spark makes using them incredibly clean. On the driver, you just wrap your big chunk of data in a call to sc.broadcast. Then, inside your worker code, you just use .value to access it. Spark takes care of all the heavy lifting and efficient distribution behind the scenes. It's brilliant.
So let's just recap the key things to remember. First, they are read-only. The workers can't change them.
Second, they're sent just once per node. Third, they use a really cool, efficient BitTorrent-like protocol so your driver doesn't get swamped. And a little pro tip, if you're really trying to squeeze out performance, the serialization format matters. Using something like Cryo can give you a nice speed boost. So really, it all boils down to this simple idea: the direction of your data flow. If you need to gather information from many workers back to one driver, you want an accumulator. Think of it like collecting votes. But if you need to scatter information from one driver out to many workers, you want a broadcast variable. That's like sending out a company-wide memo. If you can remember gather versus scatter, you'll know exactly which tool to reach for.
And that brings us to the end. I want to leave you with a question to mull over. These two patterns, gather and scatter, are some of the most fundamental building blocks in all of distributed computing. Now that you can spot them, what kinds of problems in your own work could be simplified just by thinking about them in this way?
If this helped clear things up for you, we'd love it if you'd hit that like button and subscribe for more explainers like this one. Thanks so much for tuning in, and we'll catch you on the next one.